Hi and welcome back to another video. It's been quite a long time that we did some kind of mainboard review. We have an MSI Z790 MEG Ace, and already with Z690 MSI had quite decent boards with a lot of also interesting overclocking features, which I want to check out in today's video. Let's go. Before we start with the board and assembly and testing everything, I just want to give you an overview about some, from my perspective, very interesting and cool features. We also will take a look at the VRM components and also disassemble this, but before we get to that, quick overview about some nice features. It's a 4-slot board. From the memory side, we have a voltage measurement point, so if you want to check your V cord during overclocking, for example. Also debug LED, very important feature, every board should have that. But we will focus now on the bottom area of the board, starting off with the M.2 connection and also with this slot, which has this kind of unique feature that you don't need any kind of tools to disassemble it. If you press this right here, you can unlock it and then take it off from a magnet that holds down the entire piece. We have this tiny connector in front, which is forming the connector from this piece right here to the built-in RGB. So that's pretty much it. And this way you can mount your M.2 without using any kind of screwdriver. Honestly speaking, I'm not quite sure how important or necessary this feature is. I mean, you're building your PC, you have to screw down the mainboard, you need tools anyway, so yeah. I don't know. I mean, it's something that could be cool, but it's kind of also a little bit unnecessary. I want to point out that the M.2 0.1 connector is directly connected to the CPU. You can easily find that out on this board by looking at some of these tiny charts you can find everywhere that indicate what kind of connection the slot has. Will be easier to see on the surrounding M.2 connectors. Before I'm going to disassemble this and also take a look underneath, I quickly want to talk about the design of the board. So we have an RGB area here on the removed shield and on here. And also, I mean, the entire board is kind of black and gold, which I'm personally a big fan of. I like black and yellow and black and gold. But I'm not quite sure how nice it is or how wise it is to have this as a general color scheme, because I think it will limit your customer base. Because if you're looking for maybe a black and red build or a black and blue build or something, and you might want to do that with your RGB, it's kind of interfering with your design. So I'm not sure if it's a good choice to have black and gold. Might be better to have this a little bit more universal. Very tiny thing, probably nobody would complain about that, but just from a technical aspect, any of these covers should not have threads, because if you want to clamp something down, the top part should not be threaded. So make sure, MSI, that you have through holes on any kind of covers. And on the bottom, I mean, you have the threads here, so that's all fine. But on this piece or pieces like that, you should avoid having threads in there. I know that in theory, this is so you don't have to remove the screw all the way. But the thing is, if you screw it out, you never know if the thread is still stuck underneath there or if it's already in here. So in the end, I always end up completely removing the screws, because I just cannot tell if it's stuck in the top part or the bottom part. With all the covers removed, we are greeted by a shit ton of M.2 slots with a lot of thermal pads on top. One thing I want to highlight here is that these pads are dimensioned for dual-sided M.2 drives. For example, I'm using this 980 Pro, which you can see is only pretty much single-sided, so the backside doesn't have any kind of ICs. And if you would put this on there, it doesn't contact the thermal pads. I mean, it's not even necessary, so that's totally fine. And it also makes sense that they are made for the double-sided SSDs. But in case you're using a single-sided one like me, you don't even have to pull off the foil in theory, because it's not going to make any kind of contact, which is also totally fine. I mean, you have the shields on top with cooling, with thermal pads, and they make contact, so that's all fine. Also, one more thing to highlight. Those are these tables I was talking about earlier, which indicate you what kind of connection it's forming. So for example, this one would be connected to the chipset, and this one is sharing lanes from the CPU directly. So this is also stealing lanes from your PCIe slots. So yeah, just make sure that you use the right M.2 slots for your configuration. Primary one would be this one, directly connected to the CPU. And then afterwards, probably populate the chipset M.2 slots first. Now we are going to talk about some overclocking features, like great features, and some of them are hidden in a weird way. First of all, we have like power and reset. But at the same time, you also have this jumper on the right, the FS, which is a safe boot jumper. Theoretically, if you have any kind of issue, like you tune your memory, it doesn't work out, like maybe too high memory clock, and you just want to go back into BIOS and dial it down, or you might have some PCIe issue, because this is also adjusting PCIe gen speed, then you could like connect this with a jumper, but the jumper is also not included, which is quite weird. So there are no jumpers included, even though there is a ton of stuff you could do with it. Yeah, but for debugging reasons, this would be a nice feature. So MSI, I mean, you made this feature, don't hide it, make use of it. Place a switch on there so also the average user will make use of this. Same goes to the retry feature. There is this RT1, which is a retry feature, same as you have on Asus. So if something fails and you want to like just try to apply the same setting again, it's the same kind of feature. You just hit it and then you can retry or like to try to reapply the same setting again. Those should not be jumpers, they should be switches, because they're great features, should not be hidden this way. On the left we have two switches, one BIOS switch to switch between main and like backup BIOS, and we have an LED switch that allows to disable all LEDs on the board. I think for aesthetic reasons that's a good thing to have if you would just want to disable everything. You have the opportunity to use temperature sensors next to it. You can attach flow sensor, pump connection, and a ton of like fan connectors for any kind of like water cooling applications, RGB headers and everything, but that should cover most of the, at least from my side, most important features. Connectivity is not going to be the focus of this video simply because it's very subjective and it depends on your needs. We have dual internal USB Type-C connectors and also dual USB 3.0 headers for internal use. On the I/O shield, you can find 3 buttons on top. We have clear CMOS, we have a flash BIOS button to flash from a USB drive, and the smart button, which is something you can configure in BIOS, and it can also use, which is something I would recommend, to set this to safe boot. So same thing as the jumper you have internally. You can set this so whenever you press it for safe boot, then it would lower the PCIe speed, and also you can go back in BIOS and like adjust accordingly if your memory is maybe running too much on the edge. We have dual 2.5G network, we have a ton of USB Type A, Type C, dual Thunderbolt 4.0, and you can also run your DisplayPort through it. We have Wi-Fi and the audio solution. We will now take off the VRM cooler, which already looks promising just from this angle, because you can see a huge amount of surface area, and together with this type of VRM configuration, I'm pretty sure that we should see very good thermals. Almost the entire back is covered by a huge backplate that should give the board additional stability. They are advertising that it's going to like give additional stability to the memory area. And then you have like 2 of these rubber pads on here. I'm not quite sure how much like additional stability this would really give you, but I mean, it definitely doesn't hurt. And also on the VRM area, there are some thermal pads to additionally spread the heat. And talking about the VRM area, you can straight see or not see, because there are no doublers on the backside. Unlike the Godlike on the Ace, this part is not made out of aluminum. This is made out of simple plastic. This is where the RGB is located. Should still be fine. I'm pretty sure that the surface area on this heatsink will be sufficient cooling wise. The block on first look, pretty promising. We have 2 heat pipes. Each heat pipe is making contact with the power stages, like over also good quality thermal pads, not too soft but high thermal conductivity, and each heat pipe is then going to the other block. So like the second heat pipe goes from here to this block, and this way should be like all the heat is distributed evenly through the entire block. What I noticed is that on this area, which is making contact with these inductors right here, doesn't really have an imprint of the inductors, like only on the side, left and right a little bit, but in the center there's pretty much no imprint. Like this would be a decent imprint for the inductors, or like this one, but this kind of is lacking this. I don't think that thermally this will be an issue, because the majority of the heat is going to be dissipated through like the power stages, so like through this area to the block. Yeah, we will find out thermally how it will look like, but that's something MSI can like maybe look into for the future to make it a bit more perfect. But apart from that, looks pretty promising temperature-wise. VRM-wise, we are looking at a 24+2 VRM configuration. The controller obviously does not support 26 phases, so I guess we have like a twin configuration, something like this. I'm not sure how they call it, but basically like always 2 phases are active and then switching through it. But generally, I mean, those are like 105 amp power stages. I don't think you will ever be able to saturize this. You will just notice that there's like no voltage supply for iGPU. And I mean, we also did not see like any kind of like DisplayPort or HDMI connector, which makes sense because like iGPU will not be used. It's pretty similar to the Godlike. Before I'm starting to assemble my test rig, I want to quickly go back to the memory topic, because if you just scroll over the MSI website, you will see 7800 megatransfers plus, which I'm not quite sure about, because if you then change over to the QVL list, you will see that the highest verified kit is actually running 7200 megatransfers. I'm not quite sure if it's right to then advertise like 7800 plus, because I mean there are like 8000 megahertz kits out there, and you never know if your IMC is going to do that or if your mainboard is compatible with it. I mean, even this kit, it's a Dominator Platinum 7600, is officially not on the QVL list. So like in theory, I have no idea if it's going to work or not. That's something I want to check out, but like this advertising, the speed, and then not even having a single kit on the QVL list is something I don't really approve. After flashing the BIOS, we are first going to try to enable XMP to run 7600. And also, that's something I found advertised on the product page. They have this feature they call Memory Force. And like this is supposed to indicate some kind of like overclocking headroom for the DIMMs. I'm not quite sure like what actually this indicates, but let's maybe check back after loading XMP. Training was pretty quick, looked fine, I think. It straight went into the OS. I just noticed, I'm not even sure if this is normal, like it's reading 13900K here and KS here. I mean, it's a KS CPU. Pretty weird, but anyway. Memory 7600. So that worked out very well, very quick boot time. With 7600, the memory force now decreased. Maybe this is indicating the headroom that's left, which could make sense. So maybe like 8000 megahertz is the limit. I'm not quite sure. I still don't understand what this means or how it's helpful. Even though the memory seemed to be kind of stable at first, I mean, boot was no problem, but I'm just getting random blue screens. And I will just try to like open AIDA64 and maybe push some load on the memory. Oh well, that was not even necessary. So yeah, as you can see. So yeah, I mean, it's one thing like advertising 7800 plus, but as you can see, 7600. I mean, you can boot it, but at least without additional tweaking, it's not stable. With 7400 megatransfers, it seems to be running much more stable, at least like 10 passes of AIDA64 so far, no problem. I will now perform like Prime95 also for like the VRM testing, but so far, I mean, we have 112 gigabyte per second in read, 95 in write, latency 65 is also okay. There's still some headroom where you can probably like tune the latency maybe a bit with the timings. There are also presets in the BIOS which I tried, but yeah, they were like instantly unstable. So yeah, that's something you would have to tune manually probably to get it further. As you can see though, Prime95 crashed after just like 6 minutes, so it's still pretty unstable, which means that I will lower the memory frequency now to 7200 megahertz. 20 minutes more of testing in Prime95. Memory is now stable at 7200. But the thing I wanted to check is the VRM temperature at like the max possible like constant load, which you can see was roughly 330 watt pulled over like 21 minutes now. And I mean, this is with a 13900 KS at all core load, Prime95, and cooled by a Mora. So that's pretty much as much as you can put on a Z790 board. And you can see the VRM peaking out at 89 degrees Celsius. And you might now think that close to 90 degrees Celsius on VRM is bad, but we are talking about 330 watts across the CPU and like zero airflow, like zero. The fans on the GPU are not spinning, neither is the fan on the PSU, so there's like literally zero airflow going on, and this is the worst condition you could have. Like also with this custom water cooling, like there's like absolutely no airflow, and this is the highest like power draw you can get across the CPU. And if you put this in any kind of case, then you would see at least 20 degrees Celsius lower temperatures, probably more. And I also want to highlight that I tested this in a remnant from the Ashes gaming scenario, half an hour, and it was 51 degrees Celsius peak. So yeah, MSI is advertising this as an excellent cooling solution, and I totally agree. Like VRM and cooling solution couldn't be better from my perspective, because like fully out passive, worst scenario, like highest power draw ever, and it's still not throttling. So this will never limit you. One more thing regarding memory, so there are also these memory presets. This one worked out quite nicely for me with 7200. At least it could boost the memory speed in AIDA64 by about another 4 to 5 gigabyte, but with 7200, but it seemed like working nice as a preset. Also, just going back to the memory force, I could not find anything in the manual regarding this, what it's actually doing. And lucky mode 1, 2, 3 modes, which are listing to like enhance memory overclockability, but also this at least did not help me with stability going forward, like 7400 or 7600 did not help for this. Also, one thing I noticed about the power limit, so there is this, at least for me, stock setting was water cooler, which is like unlimited power target, which is totally fine for me, for my setup. Also for like a KS CPU with tower air cooler and 288 watt, I think, I mean, that's kind of possible. I guess you will still see some throttling, at least like in Cinebench or Prime95, but box cooler with a 253, I'm not quite sure. Like the jump from like a box cooler to a tower air cooler of like 30 watt, yeah. To run any kind of overclock, I would still go with thermal velocity boost on this platform. So you would first have to like set your groups of P cores, like depending on how many you want to clock. Still didn't finish this right here, but then you would go to advanced CPU configuration. Oops. Like right here, and all the way down to TVB point configuration. And I also like the way this is presented, because they actually put it in a sentence so you can understand what you're actually setting. So you have those different parameters, like the 70 degrees Celsius mark and the 85 degrees Celsius mark, and some ratio offsets. And then you can read, so for example, like stock would be, well, it's not stock, it's already overclocked, but in this configuration it would be x63 ratio if only one P core is used and the temperature is lower than 70 degrees Celsius. That's pretty easy to understand. And then you can go from there. MSI Z790 Ace conclusion. Generally speaking, at least for my personal preference, it would be a very solid board. It's typically quite subjective, because you should always go after what kind of features are you looking for, what are your requirements, like what kind of memory speed do you require the board to run, what kind of like I/O requirements do you have. I think I also made a mistake there by the way, because I just like a few minutes ago I spotted there is a DisplayPort sign next to one of the Type-C connectors, so that's kind of indicating the alt mode, so that should probably work as like a display output. But apart from that, just looking at like the overall features and everything, for my personal needs, everything that I would need would be on there, like all kind of headers for like water cooling and stuff. I also checked, because the temperature sensors, they look proprietary, at least the connector, but you can also just fit a normal, like one of these like jumper type, like, I don't know, NTC 10K resistors on there that I have for measuring the water temperature. That also works fine. So generally speaking, I think it's a pretty solid board. The VRM configuration is pretty much perfect. The temperatures, like in also the worst condition, you're not going to experience any kind of throttling, because it couldn't be any worse like this. And the only thing I would kind of complain about is the memory advertising thing, like listing 7800 plus as like possible memory speed, and then I mean, your QVL list only shows like 7200 max, which is working. I mean, this kit is not on a QVL list, but it's also working with 7200 megahertz. I mean, just advertise this speed where you are confident with that it's actually running. You should not overpromise and underdeliver. I mean, just advertise something you are confident with that the like customer can actually use it. Otherwise, I think it might be misleading that a customer would get like a 7800 kit, tries to run it, it's not running, he will like be dissatisfied, he will be mad and then like have a bad experience. I think like recommending something lower would be the better way. I mean, first of all, you would have to even check if it even makes sense to get this kind of like memory kit, like 7200 megatransfers. It's usually twice the price than like a good 6000 or 6400, and they are usually sufficient when it comes to like bottlenecking and everything. That's why, I mean, that's something up to you, very subjective, but I would say that if you're looking into this board and it has the features that you're looking for, I would recommend it. Thanks for tuning in, see you next time, bye bye.